Try to contain yourself. Okay. Anyway, guys, if I could have your attention, please. So what I wanted to do, I was driving in on my way to school to school.
Okay.
Already messing up. Okay, I was driving in on my way to school today, and I was wondering for some reason I was wondering who can throw the ball the hardest.
Me.
And I was thinking it's probably Ben because I've seen him play baseball and he's pretty darn good. But then I thought, I don't know, Gino is shy, but maybe he can throw a ball really hard. Maybe he can throw the ball faster than Ben.
I can throw a ball. I can throw a tennis ball.
Sam's not big, but she has a lot of energy. Maybe she can throw a ball really fast. I don't know.
Yeah, if he does, big muscles and buff.
Yeah, maybe because Dallas is so buff, he can throw the ball the
Hey!
So, but then I went and told Mr. Wah my problem. I went around looking for a speed gun. I couldn't find it because I wanted to know who could throw the ball the hardest. So I went to Mr. Wah and explained the problem, and he handed me some meter sticks, and he was like, here you go. And he handed me these. And I was like, what am I supposed to do with these? How is this going to help me find the rate of throwing a tennis ball? And he goes, I don't know. You know what, Mr. Jolly? I'm busy. Figure it out.
Just best friend ever, Mr.
I was like, fine. So I took the meter sticks, and then I went to talk to Mr. Brooks to see if he knew. So he goes, well, you have meter sticks, and he handed me a stopwatch, and he goes, here, just use this in the meter sticks. I was like, Mr. Brooks, what? How? And he's like, I don't know. You know what, Mr. Jolly? I've got a bunch of stuff to do.
Loner.
So I got the stopwatch, and then I've got meter sticks and a stopwatch, and I'm like, what am I supposed to do? You guys know any idea? Yes.
Yeah. You throw it and then you time it, and then this one is the ball, and it's like random and it stops, you can stop it, and then you can.
What?
You divide this by this, and you use that. Because like when you throw the ball, you can start timing it, and then once it reaches the end of like where it stops, you can stop it.
Great timing.
I think I remember. I think I know what you're getting at. I think I remember learning this just recently, right?
Oh, you know! I thought you were just like joking and like, oh, I don't know what to use with it.
I think I recall. This is so
Mr.
weird.
Jolly totally doesn't know what
Yeah.
We've got to figure out what the rate is. So
Why
we've
did
got to
I
get
ask-
rid of the T. So how are we going to get rid of the T?
Divided by T.
Zion, are you recording
Why
this?
did I actually believe this?
Mr.
was
Jolly,
wrong?
Are you putting this on your Facebook post? That rate times time equals distance? Alright. Please try to pay attention. Okay, so the T's are going to cancel. So R is equal to D over T. You mean we can do it this way, Yasmin?
Yeah.
Okay.
Sounds like
What?
very like forced advertising.
It's-
Please divide
Alright, so what we're going to do is go to the pavilion. And,
No.
and then we're going to measure. And obviously, the farther away, and we're going to throw the ball at the net as hard as you can. Okay? Don't throw your arm out. Don't throw it so hard that it'll hurt your arm. Okay? So, anyway, we're going to measure from the net. So let's say this is the net, and I had a professional artist draw this actually.
Oh my
You would
goodness.
know.
Is that you?
And you're going to measure. And you're going to try to be as far away from the net as you can possibly throw the ball in a line drive, okay?
In a straight line.
In a straight line. So what's the reason why it has to be a straight line? What if you throw the ball like this? What's going to happen? What force comes into play and affects the rate? Gravity, yes. And also
Why are we in science?
you're going to have a longer distance. So that's going to skew it, okay? So young. What happens if you throw it up here? What's the problem with that?
It goes to the space. It goes to space.
Too much potential energy wasted.
It goes to
Yeah, that's true. So it's working against gravity, and also what's happening.
So it's
It's a longer distance because it's a triangle.
Isn't that good?
You want to throw it as straight as possible so we get the best results.
Mr. Jolly,
Please, let me finish my little spiel and then I'll call on you, okay? Okay, so listen. You're going to measure from the net with the meter sticks. You're going to have one timer, one recorder, and you're going to have one person, you're going to have one thrower. Now I have one group that they all wanted to compete. They all wanted to see who could throw harder. If you want to do that, you can. You can just record all three. You can rotate. You can do it that way if you want. But the farther away from the net that you are, the more accurate the timing's going to be. I think for pretty obvious reasons. Why is it? Because you're going to be stop, start, stop, start. Okay, so it's difficult at times. So try to be as accurate as you can. So as soon as the ball leaves, actually as soon as the thrower is like at this point, it's about to leave the hand, start it. As soon as it hits the net, stop the time. And you're going to have the time below.
Yeah, I should do that.
So let's say, for example, you measure 10 meters, and let's say it takes 1.2 seconds. You are going to find the unit rate, like we just discussed, by dividing the top by the bottom. That'll be the next step. I've got the worksheet, and it has all the steps outlined, and then it has a bunch of dimensional analysis stuff to do. Like you're going to go into kilometers per second, then you're going to go into kilometers per hour, and then you're going to go into miles per hour. The fastest pitch in the world was 161 miles per hour. No, 161 kilometers per hour. So,
Miles per hour? Imagine you just stood in front of it. And it's like, oh god.
I'm actually going to show you that pitch in a second on YouTube. I forgot to show it, but I'll show it.
One day a baseball hit my head and then I got a surgery and then I died. I bet that happened in my...
Let me finish this and then we'll talk baseball, alright? Talk baseball.
Are they part of the Red Sox?
Mr. Jolly.
I'll show you the video. Wait, just let me finish. I'm almost done. So anyway, so like I said, we're going to go to the pavilion. We're going to be orderly. We're going to all go there together because I've got to figure out where the gym classes are, and we have to stay away from the gym classes. You're going to measure from the nets. You're going to get a thrower. You're going to have a timer. Try to be as accurate as possible. Now, last time Ellis is bragging. He told me he's going to tell the entire 8th grade that he threw the ball harder than Mr. Jolly.
Oh yeah, he told me and that was.
He is so annoying. I want to punch him in the face.
And as we know, that's impossible because there is a lot of human error that's involved in the timing. It's very difficult. So I took the liberty, and I'm gonna challenge Ellis for a rematch.
Go,
But
Mr.
I
Johnny.
took the liberty of downloading a SpeedGun app. So we're gonna try to use this to help. I had our technical maestro here. Jared's downloaded a SpeedGun app as well. So we're gonna try to get some more accurate results and figure out in case there's some human error involved in this experiment. But otherwise, this is about dimensional analysis and the conversion. So we're gonna collect the data, we're gonna come back to the room, and then we're gonna go ahead and do the dimensional analysis part of it. We're gonna convert it, we're gonna figure out how much it is in miles per hour. Sam.
Do you know like those dog thrower things? So you like throw the ball and then the dog goes and then he takes the ball like that.
I don't see how that's right.
No, because you throw the ball and then it goes far and then the dog has to run and then he dies.
Okay. That's a disturbing story.
Yay!
Remember, I want to emphasize, Isabel, really fast, and then you can cut. Don't throw it don't lob it. Throw it to where, find a distance from the net, where you can throw it as hard as you can, it line drives, and does not dip, and you don't have to lob it to get it there. Or else you're going to wind up getting a parabola. We're going to do a lab like quarter 4, I think that involves parabola.
But Mr. Jolly, that's pretty. It's a rainbow. Why would you want?
Rainbows.
Yay! How can we?
So I'm going to show you the video, and then we're going to head to the pavilion. We're going to collect the data, but first we have to get the groups. I need a recorder, please. How about Sam?
Okay.
Okay, you have really good handwriting.
That's a good idea.
So please write throwers, write recorders, and write timers up on the board, and then we're going to have volunteers to see who wants to throw,
I want to be
who
thrower.
wants to time.